Hi everyone, this is section 4 out of chapter 1 and the title of this section is Angle Measure. And in this section we are going to measure and classify angles. Actually we'll also calculate angle measures if given an algebraic expression. We're going to look at congruent angles and the bisector of an angle, much like we did in the last section with segments. Okay, let's start with vocabulary and key concepts. We're going to begin with a ray and opposite rays. A ray is something sort of in between a line, which goes on infinitely, and a segment, which has endpoints. So a ray does have one endpoint here. It is either called an endpoint or initial point. And you could think of initial as a starting point. And a ray goes on and on forever through another point. The way we notate a ray in this example, we would say x, y, and in this case, we're going to put the bar over the x, y, the 2 points that are on that ray, and we're only going to show one arrow. Unlike a segment, the order of the letters does matter in this case. So if x is the initial point, the starting point, then x has to be first. And if the ray is going through y, then we would show that with the arrow over that y. So in this case, the order matters. So maybe we should write that down. Must be initial point. Okay, opposite rays are those that go in opposite directions. So over here, and forming a line, if you could see that. Over here, we could say that ray BA. So here, BA. If we look at this ray here going this direction, it starts at point B and goes through A. BA and BC are opposite rays. And you can see that they form a line, and we can actually call this line AC. Okay, why do we talk about rays? Because rays are what forms an angle. So here we have an angle shown in the diagram, and the angle is really this space here in between these two rays. So we could say an angle is formed by two rays, and they have a common endpoint, or let's just say endpoint for now. And in this case, the common endpoint is B. We call that common endpoint the angle vertex. So we're going to say that this is the common endpoint. And in this case, when we have these two rays, we have ray BA, and we have ray BC, and they have a common endpoint, which is point B, and that's the vertex of the angle. Interior to that angle, that means inside. So everything in this area here, I'm just going to put a little blob here. So everything inside that angle is interior. Everything out here is exterior to that angle. And of course, exterior is another word for outside. And the sides of this angle are the rays that form it. So these are the sides to the angle. Now sometimes, in the case of shapes, quadrilaterals, triangles, etc., they may not be rays. They may actually be segments. So an angle can also be formed with segments. So we should write that down. Alright, let's keep going here. Now how do we name angles? Well, there's a variety of ways that we can use to notate or name an angle. In this diagram here, there are three different ways we can name this angle. We can name this angle with numbers, I'm going to abbreviate, or letters. Okay, so method one, let's say. The first and easiest way to name this angle is with that common vertex. So here, this common endpoint, this vertex B, we could use an angle symbol, which is this, or you may see this little arc here on that angle symbol. So we could call that angle B. Angles, so that's using the vertex. Angles are also named with numbers. So I'm going to say method 2. So here, that angle B is being labeled with a number 1. So we could say angle 1 or angle 1. And then the third approach, third method, is my least favorite, but there are times when we must use this, is to use 3 letters. So up here we could say angle A, B, C, or angle, I'm going to use both of these symbols, CBA. So A, B, C, or CBA, what do you notice? That vertex, that common endpoint, has to be in the middle. So that order does matter. Now looking over here to the right, you can see that there's multiple angles going on here. We've actually got 3 angles, and I'm going to show you how to mark them. We've got this angle. I'm going to mark that with an arc. We've got this angle, and it's not the same measure as the one I've just marked, so I'm going to use 2 arcs. And then I'm going to change colors here. We've got this angle. So there's a lot of angles going on there. So in this type of diagram, we cannot use the notation angle B any longer because it's unclear what angle of the 3 we would be talking about if we talk about that common endpoint or vertex B. So we cannot, oops, I forgot my E here, we cannot use angle B. Consequently, let's put some numbers in here, and just to make things clear, I'm going to erase these for a second, and I'm going to label angle 1 and angle 2. So the largest angle here, I cannot use a number for. I can't put, say, angle 3 on this ray in the middle. That's not going to work. So the largest angle, I have no choice but to use the 3 letters. So I'm going to say largest angle. I have to label with the 3 letters. I'm going to use my angle symbol, A, B, C. So the largest angle is contained in here, A, B, C. Now, angle 1, I could label, or I could say angle A, B, D. And finally, angle 2, or angle D, B, C. So hopefully this is clear. It's very, very important that you're able to read this notation and identify what angle it is referring to in a diagram. And it's also very important that you're able to read this notation and draw your own diagram. Okay, now what types of units do we use to measure angles? Well, the unit that I'm sure you're mostly familiar with is degrees, and of course the symbol is the same type of symbol that you would use for temperature, such as degrees Celsius or degrees Fahrenheit. Obviously 2 very different concepts, however. So here is shown a circle, and the standard way that we measure angles in a circle would be counterclockwise. So going in this direction, counterclockwise, and if you look here, we would start over here at 0 degrees, and we'll start to increase our degree of measure. A straight line or a straight angle is 180 degrees. I'm sure most of you know that. And the angle measure for a complete rotation around a circle would be 360 degrees. Now, there are other units of measure for angles. One of those is called radians, and I'm sure that you have not had any experience using radians. We will predominantly be using degrees through most of this year, and we will be looking and introducing radians at the end of the year when we do trigonometry. But just to give you a quick idea, if we had a complete circle, as you know, the length around that complete circle is called the circumference. And the circumference, if you remember the formula, the circumference of a circle equals 2 pi times the length of the radius. So in other words, if we had a complete circle here and we took some scissors and cut it and we straighten this whole thing out like a long piece of string, the length of that would be 2 times pi times the length of the radius of the original circle. So if you think about that, a complete 360 degree rotation is 2 pi. And consequently, if you look at, say, a quarter of that length, that would be 90 degrees, then you would have 2 pi divided by 4, because it's a quarter, and we could simplify that to pi over 2, and that's why 90 degrees is equivalent to pi over 2 radians. So don't worry too much about this right now. We will definitely be picking back up with radians at the end of the year. Now, how do we measure angles? Well, we measure angles with a tool called a protractor. And many of you have probably seen this before. A protractor looks like a semicircle. All the ones we use in the classroom are plastic. And you line up this center point here, right here. You line that up with the particular angle that you want to measure, and you can see that there's 2 scales. You have an outside scale and an inside scale. The outside scale on this particular angle that we're measuring says 130, and the inside scale is measuring 50. So this angle here, I'm going to mark it in blue, this angle here is 50 degrees, and the 130 refers to this angle over here. And so you can kind of measure the 2 angles that form a straight line all at once. Classifying angles, most of you have seen this for years. This symbol here is for a 90-degree right angle. So this is a right angle, and right angles are 90 degrees. And anything less than 90 degrees, is called acute. And if you recall, anything greater than 90 degrees, such as this angle here, is called obtuse. So on the previous slide, when we looked at how to measure an angle, that 130-degree angle would have been the obtuse angle, and the 50-degree angle would be acute. Angle bisector, just like we talked about a segment bisector, an angle bisector is the thing that's doing the cutting. So bi means 2, and in the case of a bisector, we're talking about 2 equal halves, just like a segment. And sect or means to cut, to separate. And in this case, we're going to cut an angle in 2 equal halves. So here in the diagram, we're showing an angle LKJ being bisected. Now, how do we know that? We know that because these two arcs are showing that the two small angles are congruent. If we had another diagram, by contrast, something like this, I'm going to purposefully make a very skinny angle. Clearly, this angle is not congruent to that angle. Therefore, I've got to show one with a double arc and one with a single arc. It doesn't matter which one, but the point is we're trying to differentiate the two by showing them not to be of equal measure. In this case, we're showing congruent angles, and we're showing that with the single arc. So, we know if we have two equal halves then this ray KM is a angle bisector. So we're going to write that down. KM is a ray, and it's an angle bisector. And we know that again because the diagram is showing us two equal angles that are congruent. And we would write that, again, we can't use the letter K to name this angle over here. There's three angles over here. So we would have to write this as angle LKM is congruent to angle MKJ. So that's the only way we can write a statement of congruency. And I'm going to write that right down. Statement of congruency. So just like segments, we use the same symbol for congruent angles as well. All right, let's take a look at some examples. Name all the angles that have B, point B, as a vertex. Again, we talked about this before. B is a capital letter, so it is kind of in the place of an angle in there, but it's not naming an angle, and we know that because it's a capital letter. That would always be naming a point. So let's look at all the angles there. We've got no number inside where that B is located. So that angle there is going to have to be called angle ABG, or we could have called it angle GBA. That has a vertex B, and we would know that because it's in the middle here. We also have angles 5. We have angles 7 and angle 6. So all of those angles have a vertex that is point B. Name the sides of angle 5. Angle 5 has sides here. I'm going to make them in red. Angle 5 is being surrounded by those two rays. So we could say the side of one side of angle 5 is BG, and that's a ray, so we have to put that B first. And the other side is B. We could call it E, or you could have named that BF. Either one is acceptable. So, sorry about that messy F. But either one is fine, but the B has to be labeled first. Okay, number 3. Which angle has point X as a vertex? Here, it's a capital letter, X, so we know that is labeling that point there. What angle has that as a vertex? Well, we're going to have to go one by one. Angle XBY, so XBY, that does not have X as a vertex. And we can eliminate that even if we didn't look at the diagram, because if it had X as a vertex, you would see X in the middle position here. YAX, well, we can eliminate that for the same reason, so it must be angle AXB. Let's look at that angle, AXB. That would be this angle 3. And that certainly does have X as a vertex. Classify each angle listed. Angle TYV. So let's look at TYV. TYV is a 90-degree angle. It's a right angle, and we would know that because it's forming a straight line with another right angle. So a straight line is 180 degrees, If I subtract 90 degrees from that, I get 90. So we would say this is 90 degrees, and it is a right angle. Next, angle TYX. TYX forms a straight line, so that is a straight angle. And we could say that's equal to 180 degrees. UYX. UYX, that is greater than a 90-degree angle, so that would be obtuse. We don't know the measure of it. We don't have enough information, but we do know that it's greater than 90, so it is obtuse. And VYW is less than 90, so we would say that is acute. Again, we don't know the measure, but we can certainly classify it. Okay, example number 5. Measure and classify each angle listed. We're going to use the protractor diagram here. Okay, angles CZD. CZD is greater than 90 degrees, so that is classified as obtuse. And we can read over here using the outside scale. It is 150 degrees. Next example, XZD. XZD is forming a straight line with the previous example, and that is acute, and it is 30 degrees. Next example, XZE. XZE is forming a 90 degree, so that is right, and 90 degrees. And finally, CZX. CZX is straight. That is a straight angle, and straight angles are 180 degrees. Finally, example 6. Ray SA is bisecting angle RST. We don't have a diagram, so the very first thing we're going to do is draw a diagram. So we've got some kind of angle here, and that angle is RST. We know that S is the vertex because it's in the middle position. We're told that ray SA is bisecting this angle. So SA is a bisector, therefore these two angles here are congruent. Now notice I don't put one big arc here. One big arc there would be very hard for us to see what angle is being drawn. So you have to offset these arcs a little bit so that you can see what angle is being notated. Alright, so now we're told that the measure of RSA is an algebraic expression, and I'm going to write that in there. So RSA is this angle here, and it is 6x plus 2, and we're told that the measure of AST is also an algebraic expression, and it's 10x minus 14. We know that those two angles are congruent, so we would say that angle RSA is congruent to angle AST. And now we're just going to substitute. So we've got 6x plus 2 is equal to 10x minus 14. If those angles are congruent, their measures are equal. And I'm going to subtract 6x from both sides, and I'm going to add 14 to both sides. So I get 16 equals 4x. Divide both sides by 4, and I get x equals 4. Now that's part of our solution, but we were asked to find the measure of RST. RST is the big angle here, RST. So we're going to substitute x equals 4 into each of these expressions. So I'm going to start over here. 6 times 4 is 24, plus 2 is 26 degrees. So RSA is 26 degrees. I'm going to substitute x equals 4 here. 10 times 4 is 40, minus 14 is also 26 degrees, which we would expect that those two are congruent. Therefore, if I add those two angles together, we will get an angle of RST, the measure of angle RST, to equal 52 degrees. Thanks for listening. Take care.